We have been working with ratios and proportions, and today we're going to look at that a bit more in context, and specifically in the context of solving word problems. And we're going to solve each problem multiple ways so that by the end of it, you should have several different methods that you could use to solve problems. So here's our first problem. At a special sale, you can buy 3 DVDs for $24. How much would it cost to buy 9 DVDs? And I gave you a hint to look for a ratio you know. That's going to be in our first sentence. I'm going to solve this problem 2 ways, so I'm going to go ahead and split my screen in half right here so that I can space it out and have space for both ways. So one way that I can solve this is by using equal ratios. And I have to say, this is probably my preferred method for most problems when I can use it, because it's pretty easy to set up and understand, and it's sort of my go-to method. And this is where we use our bridge map. Now, if you remember, the first 2 sections of our bridge map are the things that we know. So what we know, the ratio we know, is that I can buy 3 DVDs for $24. So I'm going to put that in my first section of my bridge map. So I'm going to say, well, I can buy, it's $24 to buy 3 DVDs. And I could put the DVDs on top and the money on the bottom. It wouldn't matter. The only reason I put money on top is because we were sort of in the habit of doing that when we do unit pricing. And now the last part of our bridge map is going to be where we put our question. So our question says, how much would it cost to buy 9 DVDs? So 9 is our number of DVDs. It's going to go on the bottom. And the question is, how much would it cost? So we're looking for the cost. So that's my missing number. Now there's a few ways we could do this. One way we could solve this is we could use a scale factor and say 3 times 3 is 9. So we have to do 24 times 3 to get our answer. And when we do that, it's 72. So my answer actually is $72. I could have also solved that by cross multiplying and then dividing. So 9 times 24 divided by 3 gives me x. And if I were to work that out, I would in fact get 72. So equal ratios are one way I could solve this problem. Another way I could solve this problem is I could use a ratio table. We've spent some time working on ratio tables. And if I wanted to set up a ratio table to represent this situation, I would write, what are the 2 things being compared? Well, we're comparing the number of DVDs I can buy to the cost of the DVDs. I know that 3 DVDs cost $24. What I want to know is 9 DVDs cost how many dollars? So I could set this problem up just like that. So this is just like ratio tables we've done that have a missing number, and we use the ratio we know to find the information we don't know. So one way I could do this is I could say, well, 3 times 3 is 9, so 24 times 3 is 72. I could totally do that. Now, I want you to notice that if I look at this really closely, actually this is really quite similar to the way that we just did it with the bridge map. Because when I look at this, I have the ratio of the cost to the DVDs is 24 to 3 is how much to 9. So it's really kind of the same question. It's just presented a different way. And that's one thing you'll find is that even though we're going to look at several different methods, the methods are really all related. In some cases, they're just different ways of showing the same thing. Now, some of you might have also realized that you can actually also solve this problem by using the constant of proportionality. What I mean by that is you could have said, well, 3 times 8 is 24. So I can do 9 times 8, and that also gives me 72. And I'm using my constant of proportionality, which is like my unit price there. So those are 2 ways I could solve that problem. Let's look at a couple more problems. So for this problem, you get paid $8 for 2 hours of babysitting. How much for 7 hours? We're going to actually solve this problem 3 different ways. We're going to use equal ratios because remember, I told you that's my favorite. I think that one works quite well for almost all problems. We're going to also use unit rates. And we're going to use a double number line. So let's start with equal ratios. We're going to use our bridge map. When we look at the first sentence here, we can see that the two things being compared are $8 for 2 hours, or we look at the first part of the sentence. It's $8 for 2 hours of babysitting. So $8 for 2 hours. And then the question part of this says, how much for 7 hours? That means how much money for 7 hours. So when I set up the rest of this, I'm going to do how much money for 7 hours. Now notice there's no whole number scale factor I can use here because I can't do 2 times any whole number and get 7. That's where it's really important to remember that cross multiply and then divide. So I would do 7 times 8, which is 56, and then divide by 2 to get x. And when I do that, my missing number is going to be 28. So my answer is I would get paid $28. Now, let's look at a couple of other ways of doing that. So looking at this way, the unit rate. This is really similar. We're still going to say $8 for 2 hours is equal to how much money for 7 hours. But before we get to that part, we're going to figure out, well, how much money for 1 hour. That's where we're finding the unit rate. So we would say, well, 2 divided by 2, or times 1/2, is 1. So we're going to do 8 divided by 2, or times 1/2, and that's going to give us 4. So it's $4 for 1 hour, and then I can do times 7 to get 7 hours. So 4 times 7 is 28. So I could get $28 that way as well. So my using a unit rate. Now I don't have to find a unit rate, but some people just like to find a unit rate. They feel like that's a little bit easier. And then the final way that I want to show you is using a double number line. And a double number line is exactly what it sounds like. It's 2 number lines. You use 1 number line for each of the things that you're comparing. So I need 1 number line for dollars and 1 number line for hours. And if I work for 0 hours, I make $0. Now, I know that if I work for 2 hours, I make $8. So I am going to say, well, 2 hours should line up with $8. So in other words, I'm going to count by 2s for the number of hours and count by 8s for the amount of money. And those should line up. So 2, 4, 6, 8, 10. And then when I count by 8s lined up directly across from them, I'm going to get 0, 8, 16, 24, 32, 40. Now, I want to know how much I get paid for 7 hours. Well, 7 hours isn't actually on here, but 7 hours would be between 6 and 8. So I need to know what comes between 24 and 32. And if I want to know what comes between them, there's a few ways I could do this. One way I could do it is I could say, well, let's go back and figure out what comes between all of the numbers. So 2 divided by 2 is 1. 8 divided by 2 is 4. So that means for 1 hour, we get paid $4. So I could go back and say then, well, if it's $4 for 1 hour, then 1 times 7 is 7, and I could do 4 times 7 to get 28, which is going to go right here. Another way I could look at that is basically using the idea of constant proportionality is I could say, well, 2 times 4 gives me the 8 that's right here. 4 times 4 gives me 16. 6 times 4 gives me 24. So I would have to do 7 times 4 to get 28. So $28. Any of those ways works, and any of them is an equally valid way. The best way is the way that works the best for you. All right, let's look at another problem. It takes 3 cups of sugar for 4 gallons of tea. How much sugar for 20 gallons? I'm going to show you 2 ways to do this problem. For this problem, we're going to, of course, use equal ratios. And we're going to use a tape diagram. So if I use equal ratios, I'm going to first find what are my 2 things that are related. And when I look at this, I'm going to see, oh, it takes 3 cups of sugar for 4 gallons of tea. So those are my 2 things that are related. So I'm going to put that in my bridge map. I'm going to say, well, it takes 3 cups of sugar to make 4 gallons of tea. And I could put my units here as well. And the question then is, how much sugar for 20 gallons? So how much sugar for 20 gallons? That's what I need to answer. So that's what's going to go in my last section. So in my last section, how much sugar for 20 gallons of tea? The X goes on the top not because X always goes on the top. It goes on the top because we're looking for the amount of sugar, and sugar is on the top. The 20 goes on the bottom, not because we always put a number on the bottom, but because the 20 is an amount of tea. So tea goes on the bottom. Now, I can work this out. I could use a scale factor on this one. 4 times 5 is 20, so I can do 3 times 5 and get 15. I could have also, if I wanted to, cross multiplied and then divided. And if I did that method, I would do 20 times 3 and divide by 4. And when I do that, I'm still going to get 15. Okay, tape diagram. This is the 5th method I will have shown you for solving these kinds of problems. So a tape diagram for this would look like this. A tape diagram is where you draw boxes to represent the ratio. So I want the ratio of sugar to tea. And that ratio is 3 to 4, 3 cups of sugar for 4 gallons of tea. So I'm going to draw 3 boxes because my ratio is 3 to 4. 3 boxes for sugar and 4 boxes for tea. So that represents my ratio of 3 to 4. Now I look at the question part of it. So what's highlighted in yellow is what I've represented so far in my tape diagram. The blue is what I need to put in now. It says how much sugar for 20 gallons. So that means I want to know this. I want to know how much sugar if I need 20 gallons. So in other words, if those 4 boxes have to stand for 20 gallons of tea, then how much sugar am I going to need for that? Well, 4 boxes standing for 20 gallons means that each box has to stand for 5. And I'm going to actually take off that unit because I don't want that to be misleading and for you to think that my sugar is going to be measured in gallons also. It's not. We're still going to use gallons for tea. Oops, we're still going to use gallons for tea, and we're still going to use cups for sugar. So each of the boxes for tea has to stand for 5, and the reason is because there are 4 of them, and the total has to be 20. And 20 divided by 4 is 5. If each of those boxes stands for 5, then each of the boxes for sugar also has to stand for 5. And so what that means is, if I have 3 boxes that each stand for 5, 3 times 5 is 15. I need 15 cups of sugar. Notice I still get the same answer as what I got for the last problem. And something else I want you to notice is the scale factor I used over here is the same as the number that's inside the boxes. So again, these methods are not completely unconnected. I want you to realize that they do have some things that are going to be shared about them. All right. This next problem I want you to try. And once you've tried it, I want you to pause while you're trying it. And then once you've tried it, I want you to hit play and see if you did it correctly. Now, if you've done it correctly, you should have gotten 7 fourths. And there's multiple ways you could do this problem. You could do it using the double number line, using tape diagrams, using unit rates, using any of the methods we've talked about. I just used equal ratios because that's my preferred method. But whichever method works the best for you and consistently works, that's going to be the best method to use. All right. Let's look at one last problem together. A punch recipe calls for only 2 ingredients. It needs 2 parts ginger ale and 3 parts orange juice. If the punch bowl has 8 cups of ginger ale, how many cups of punch are in the bowl? We're going to solve this one using 2 methods. We're going to solve it using an equal ratio, and we're going to solve it using a tape diagram. I may throw in a couple more here as well. We'll see. So a punch recipe calls for only 2 ingredients. It needs 2 parts ginger ale and 3 parts orange juice. So we might look at this and say 2 parts ginger ale, 3 parts orange juice. And then the question says if the punch bowl has 8 cups of ginger ale, so my 8 goes here, how many cups of, it doesn't say how many cups of orange juice. It says how many cups of punch. And I've got orange juice. This isn't going to work. I can't just put an X here and solve it and that X is going to be my answer. So we got to think about this. I'm going to come back to this equal ratio method in just a minute because what you've just now realized, hopefully, is that the ratio that we're given, which is this ratio right here, 2 parts ginger ale and 3 parts orange juice, doesn't match what our question's asking because our question asks for 8 cups of ginger ale and how many cups of punch, not how many cups of orange juice. So that means that an equal ratio method is going to be a little bit trickier to use. Not that we can't, we can, but it's going to be a little trickier. So in a case like that where we have a part-to-part ratio, but then we have to think about the whole also, I have a couple different ideas for how to solve that. One way that really helps with that is to use a tape diagram because we can say the ratio of ginger ale to orange juice is 2 to 3. Now what's really nice about this method is I can see my parts, ginger ale and orange juice, 2 parts ginger ale, 3 parts orange juice, but I can also see the whole. The whole is 5 because I put the 2 parts ginger ale and the 3 parts orange juice together, that makes 5. Now, I can solve this by looking and saying if the punch bowl has 8 cups of ginger ale, so this has to stand for 8, then how many cups of punch are in the bowl? That means I need all of this together. How many cups of punch? So now when I can figure out how much is in each box, because that's really what I have to do. If I can figure out how much is in each box, then I can figure out the question. 8, there's 2 boxes. 2 boxes equals 8. 8 divided by 2 is 4. So these boxes have to each equal 4, which means these boxes have to each equal 4. So a couple ways I could look at this. I could look at it and say, well, there's 8 cups of ginger ale, and there's 12 cups of orange juice, and together that makes 20 cups, and that's my answer, and that is correct, by the way. Or I could say, well, there's 5 boxes total, and each of them is worth 4. 5 times 4 is 20. And so that method would work. So again, the nice thing about the tape diagram is it allows us to see both parts and the whole at the same time. Whereas an equal ratio, when we do a bridge map, doesn't allow us to see that. But what you hopefully now should see is it's going to be more useful perhaps to solve this problem by saying the ratio of ginger ale to punch. And you might say, well, that's not the ratio that's given to me. And it's not, but it is a ratio we can figure out because we know that the punch is made from ginger ale and orange juice. And if I put those together, 2 parts ginger ale plus 3 parts orange juice, that gives me 5 parts punch. And so that's where that 5 comes from. So the ratio of ginger ale to punch is 2 to 5. And if I want to know then 8 parts ginger ale, how many cups of punch do I need? Then I could set it up like this. And again, notice 2 times 4 is 8, 5 times 4 is 20. So I get 20 cups that way. I'm actually going to show you 2 more ways you could look at this problem. You could look at this problem, and this is just a different kind of model for this. You could look at this and do something as simple as saying, well, I'm going to use 2 parts ginger ale and 3 parts orange juice to make my punch. But I need to actually use a total of 8 parts ginger ale. So I'm going to continue adding 2 parts ginger ale and 3 parts orange juice until I have a total of 8 parts ginger ale. Do I have 8 parts ginger ale yet? No, I've got 4. So add another row. Now I've got 6 parts ginger ale and 9 parts orange juice, but that's not enough yet because I need 8 parts. I need 8 cups of ginger ale. Now I've got 8 cups of ginger ale. And when I look at the total amount of punch, 8 cups of ginger ale, and I have 12 cups of orange juice, my total is 20 cups. So I would have 20 cups of punch. Last but not least, I could also do this using a ratio table, because the nice thing about a ratio table is you might be saying, okay, well, I can do ginger ale and orange juice. Well, I'm done. But think about it. Who's to say you can't add a third column for total punch? So 2 parts ginger ale, 3 parts orange juice makes a total of 5 parts punch, or 5 cups of punch. If I have 8 cups of ginger ale, then how much punch do I have? Well, 2 times 4 is 8. 5 times 4 is 20. So I can solve it that way. And if I wanted to, I could also come up with 3 times 4 is 12. But that's not part of what the question's asking for, so I wouldn't really need that. Hopefully, in looking back over this, you have picked out some methods that really work well for you. I strongly recommend that you consider using equal ratios for most problems, but when you're looking at a problem like this last one, where you have 2 parts that you're comparing, but you also have to consider the whole, then when you do that, I strongly recommend that you use a tape diagram or perhaps a ratio table with 3 columns. And I even like that model method. And the equal ratios work, but you just have to be really careful to make sure that you're really paying attention and you can use your 2 parts to get your whole.